In the next few slides, we will learn how to convert grams to moles or moles to grams. In this problem, we are asked to convert 65.1 gram of potassium chloride to the moles of potassium chloride. So we're going from mass to moles. And this is what we are asked to do in this problem, to change the mass of potassium chloride to the moles of potassium chloride. In order to do this problem, we need to know what the molar mass of potassium chloride is. In potassium chloride, we have one potassium atom and one chlorine atom. And if we get their masses from the periodic table and add them up, we will get 74.6 grams of KCl, and this is known as the molar mass. And this is our equality. 1 mole of KCl is equal to 74.6 grams of KCl. And since we have the equality, like we learned in the previous slides, we can set up conversion factor. And since we are going to go ahead and start the problem with the mass, then I would use this equality because we need to cancel out the grams. So when we divide 65.1 by 74.6, this is how many moles of KCl we will get. In this problem, we are asked to do the same thing, but we are doing it for acetic acid, which is C2H4O2, and the amount that is given is 25.8 grams, and we are asked to change 25.8 grams of acetic acid to the moles of acetic acid. So we are going from grams of acetic acid to the moles of acetic acid. As the previous problem, we need to find the molar mass of acetic acid, and the molar mass of acetic acid, from what we know from the previous problem, it would be 60 grams of acetic acid. To get that 60, you have 2 carbons, 4 hydrogens, and 2 oxygens. If you go to the periodic table and get the mass of each carbon and multiply it by 2, get the mass of each hydrogen multiplied by 4, and get the mass of oxygen and multiply it by 2 and add them up, you will get 60 grams of acetic acid for every 1 mole. So this relationship is known as our equality. When we get the equality, we can set up conversion factors like we did in the previous problem. After we set up the conversion factor, then we need to start the problem with what is given. And in this problem, what is given is 25.8 grams of acetic acid. We divide that by the molar mass of acetic acid, and we get that many moles. So from these 2 problems, you should have learned that anytime you want to calculate the number of moles of a substance, you need to divide the mass of the substance by the molar mass of the substance. So this is how you calculate the number of moles from the mass. You divide the mass by the molar mass of the substance. In this problem, we are given the number of mole of calcium carbonate, and we are asked to calculate the mass of the calcium carbonate. This problem is exact opposite of the 2 other problems that we just learned. Again, before we do any calculations, we need to know what the molar mass of calcium carbonate is. And if we go to the periodic table and find the mass of each element and multiply it by the subscript that we have for the element and add them up, this is what we get for the molar mass of the calcium carbonate. And this is our equality for this problem. When we have the equality, we can set up the conversion factors like we have done before. Then in this problem, again, we start with the given amount, and the given amount is 0.320 mole of calcium carbonate. And we use this conversion factor. Remember, you always want to cancel out what is given. So the mole is given in here, and the mole has to be on the opposite side so they can cancel out. And when you multiply these 2 numbers, you get that, which is the mass of calcium carbonate. So when we want to go from mole to mass, we multiply the mole by the molar mass. What is the law of conservation of mass and how it is applied to a chemical reaction? According to the law of conservation of mass, in an ordinary chemical reaction, matter can neither be created nor destroyed. It means that the mass of product is equal to the total mass of the reactants in a chemical reaction. If you look at this reaction, which is between silver and sulfur to get the silver sulfide, when we balance the equation, we follow the law of conservation of mass. So since this equation is balanced, we are saying according to the law of conservation of mass, it takes 2 moles of silver to react with 1 mole of sulfur to produce 1 mole of silver sulfide. We can't put that in terms of mass, meaning that if we know the molar mass of the silver, since it's taking 2, we multiply by that by 2, then the molar mass of sulfur is 32, and in the reactant side we have 247.9 grams. If we get the molar mass of the silver sulfide, we get 247.9 grams. And it means that if this reaction goes as it was planned, and if we are using this much of reactant, when we are finished with the reaction, we should be getting this amount of product. It is important that we understand how to use the information that is given in a balanced chemical equation to do calculations for different type of problems. In this equation, we are saying that for every 2 moles of iron, you need 3 moles of sulfur to produce 1 mole of iron 3 sulfide. And that information is shown in here. And we could use this number of moles that we have in the balance equation to relate any of these substances in the chemical equation. Based on this chemical equation and the number of moles that we have, we can set up different conversion factors using the coefficients that are given in the balanced equation. These are the information that we need to use in order to do any calculations in a chemical reaction. In the next few slides, we will learn how to use a balanced chemical equation to find the mole-to-mole factors to calculate the mass or the moles of any substances in the chemical equation. In this problem, we are given the number of moles of C3H8 and we are asked to calculate the number of moles of CO2. To be able to do this type of problems, we need to have a balanced chemical equation. And this is the balanced chemical equation. These coefficients are used to balance the number of atoms that you have in the equation. If we have the balanced chemical equation, then we can start using the moles of C3H8 to relate it to the moles of CO2. After we make sure that the equation is balanced, we need to come up with a plan how to do the problem. In this problem, we are going to use the number of moles of the C3H8 which is given and use the mole-to-mole factor that we can get from the balanced chemical equation and convert this using this conversion factor to the moles of CO2. So according to the balanced chemical equation, for every 1 mole of C3H8, 3 moles of CO2 will be produced. This is our equality. We can use this equality to set up conversion factors. This is the given amount in the problem, which is 2.25 moles of C3H8, and we need to change that to the moles of CO2. And we need to get rid of C3H8. That's why C3H8 from this conversion factor, this one goes right in here. And when you multiply these two together, then these two will cancel out. Then that's the number that you get for the moles of CO2. So far, we should have learned how to change the mass in grams to moles for a substance. Then we also should have learned how to change a mole of a substance to the mole of another substance. Then to go from moles to mass of the substance in grams. In the next slide, we're going to be using this information to go from a mass of one reactant to the mass of a product. In this problem, we are given the mass of C2H2, which is 54.6 grams, and we are asked to find the mass of carbon dioxide, which is produced in this chemical reaction, which is a combustion reaction. Before we set up our plan, we need to make sure we have the equation, and the equation is balanced. When we look at this equation, we will notice that this equation is balanced. The number of atoms on this side are equal to the number of atoms on that side. Therefore, we can use this equation to do what we are asked to do in this problem, to go from the mass of C2H2 to the mass of CO2. Since we have a balanced chemical equation, then we can set up our plan. Our plan is to go from mass of the C2H2 to its moles using the molar mass. After we get the moles of C2H2, we can use conversion factor that can be set up from the balance equation to go from mole to mole. Then after we go from mole to mole, we get the moles of CO2. Then we can use this molar mass to get the mass of the CO2. After you set up your plan, then you follow what you have decided to do to solve the problem. Like in this problem, we decided to go from the mass of C2H2 to the mole of C2H2. In order to do that, we need to divide this mass by the molar mass of C2H2. Then we said we are going to use the mole to moles ratio. So here is the moles to moles ratio according to this balanced chemical equation. After we use the moles to moles ratio, we will end up with the moles of CO2. When we get the moles of CO2, now we're going to change that to the mass of CO2. In order to change the moles of CO2 to the mass of CO2, we need to find the molar mass of CO2. So the molar mass of CO2 is 44 grams. And when we multiply the moles of CO2 by the mass of CO2, then we get the mass of the CO2 produced in this chemical reaction.